The problem states, determine the force in each member of the truss and state if the force members are in tension or compression. So the first thing we're going to do is find the reaction force at point A. We can do that by setting up a summation of moments equation. So we can say that the summation of moments about point C is equal to 900 pounds times 4 plus 4 plus 4 feet plus 600 times 4 feet minus the reaction force at A times 4 plus 4, which will give us a result of the reaction force of A equaling 1650 pounds. Now that we have the value of the reaction force at point A, we can move on and calculate the forces in each member of the truss structure. So starting off, let's take a look at joint F. So this is our y-axis, this is our x-axis. We know that there's a 900-pound load applying as such, and we have the member FA, so let's call this force FA, and also the member FE, so then let's call this force FE. We know that this the angle of FA can be characterized as the 3, 4, 5 triangle. So let's write out some equilibrium equations. So we have the summation of forces in the y direction starts with negative 900 plus 3 over 5 times the force in member FA. And this will equal the force in member FA equals 1,500 pounds, and we can indicate this as compressive. So we can use the letter C to indicate that this is a compressive force. Now let's do the same for the summation of forces in the x direction. The force in member FE plus the force in member FA times 4/5, and this will equal 0. So solving that equation, we have 1,200 pounds, and this is an compressive. So actually, wait, this is tension. So using T to indicate tension. And let's box our answers here. I will be highlighting in red each truss component we have calculated. So far we have FE and we have FA. Now let's inspect point E. So as usual, we have our axes defined properly. At point E, we have the following members. We have FE, and we have ED, as well as EA. So let's see what we get when we do summation of forces. So for the x direction, we have negative FE plus FED. And this gives us that the relation that the force in FE equals the force in ED, and we previously calculated the force in FE, meaning that the force in member ED is equivalent to 1,200 pounds. And this is in tension. Now let's do the same for the y direction. And this one will be fairly simple because the only contributing factor for the vertical direction is the member EA. Given that the system is in equilibrium, so the total summation of forces is 0, we see simply that the forces in the member EA is simply equal to 0 pounds. So the two answers we get is the force in member ED and the force in member EA. Let's highlight these members red, so this one, and we said member ED, so this one. Let's draw our set of axes again. So this is our vertical and horizontal axis. This time we will be inspecting joint A. So for joint A, we have the force in member FA, which we previously calculated. If the value of the force in member EA was non-zero, then we would also consider a vector like this. However, we calculated that the force in the member AE is equal to 0 pounds, so that's why we do not need to consider that force. So moving on, we have the force in the member AD and also the force in the member AB. And finally, we have the reaction force at A applying on this point here, and that will be in the magnitude defined here, which is 1650 pounds. So now we can do summation of forces. Oh, actually, before we do that, let's quickly draw our triangle here. So this will be 3, 4, 5, and that can help us with the angles. So let's start with the summation of forces in the x direction. So first we have the contribution of this, which is fairly simple because it's just the value. So 1650 plus, we know that the magnitude of force FA is equal to 1500, and taking the vertical component of that, multiplying that by 3 over 5, plus we have the vertical component of force FAD. I actually forgot to write out the triangle here, so let's do that really quick. So that's 3, 4, 5, and this will similarly be multiplied with 3 over 5 to get the vertical component of force FAD. And solving this equation that is equal to 0, we get the magnitude of FAD equivalent to 1250 pounds, which is going to be a compressive force. So now, I actually also realized, I know I said the summation of forces in the x direction, but I just did the summation of forces in the y direction. So now let's do the summation of forces in the x direction. So starting off, we have, let's look at the contribution of FA. So that is going to be minus 1500 times 4 over 5 plus we have the contribution of FAD, which we calculated to be 1250. So that is going to be 1250 times 4 over 5. And then we have the contribution of FAB, which is directed horizontally. So then we say plus FAB equals 0. And after we solve this equation, we get FAB is equal to 200 pounds, and that is going to be a compressive force as well. So these are our answers here. That's 1 and 2. Let's add that to our diagram. So we get, we found this member, and we've also found this member. Now let's take a look at joint B. So again, our essential x and y axes. We have the following forces applying. We have the member AB, the member DB, and the member BC. Let's start with the vertical summation, as it is pretty easy because there's only FDB applying in the vertical direction. So setting this equal to 0, we get that the force in the member dB is equal to 0 pounds. Now let's solve the horizontal, and this will also come out to be something pretty simple. And here's a hint: whenever you see a member structure that looks like this, where we have a vertical component like that and two horizontal components, so one pointing this way, one pointing this way, and then a vertical one pointing that way, you will always see that this vertical component will always have a 0 magnitude because there is no other truss component that can counteract the force that is contributed by this component here. And you will also similarly see that the magnitude for this component will be equal to this component. The reason is if this value is non-zero, then the only component that can counteract this highlighted component is this one, because there are no other components that are applying a force on the joint. So returning to our summation of forces equation, we get minus FAB plus FBC is equal to 0. And solving this, we get that the magnitude of BC is equal in magnitude to FAB. And since we have previously calculated the magnitude of FAB, we get that FBC is equal to 200 pounds as a compressive force. So let's box our answers. So this is 0 pounds and this is 200 pounds. And highlighting the components that we just calculated, we get this and that. We are almost done. The last joint that we will be analyzing is joint D. So again, we have our axes defined like this. And let's draw the free body diagram for joint D. So again, we have our load, 600 pounds. And we have two loads coming from the truss components. So we have the force coming from component AD and the force coming from component DC. We are not including the components ED and also component DB in our free body diagram because we previously established that the force in truss components ED and DB is equal to 0 pounds. So that is why we are not including it in our diagram. And again, let's draw the triangles on our vectors. So we have 3, 5, 4 here. And similarly, we have a 3, 4, 5 triangle on the other vector as well. Now let's solve the equation for the summation of forces in the y component. So we have negative 600 minus 1250 times 3 over 5 minus the force in truss DC, in truss component DC, times 3 over 5 will give us 0 pounds. And solving that equation, we get that FDC is equal to 250 pounds. Let's box our answer. And now when we look at our truss structure, we highlight the last component that we have calculated. And now we see that the whole truss structure is colored in red, indicating that we have calculated the force in every component for this truss structure. So we have successfully solved the equation. Oh, and also it is important to note that this force is in tension. Seems that I've forgotten to write that down. And that concludes the question. And shoot me an email if you have any questions.